All right, so you're trying to map out a network, but before you launch a huge, detailed scan that can take forever, you got to know what's actually online, right? That initial step is called host discovery. And today, we're diving into the absolute best toolkit for the job, Nmap's Ping Scans.
So let's just get right to the heart of it. How do you find those computers, those servers, those printers that are actively trying to fly under the radar? They're tucked away behind firewalls, set up specifically to ignore you. It's a classic cat and mouse game, and lucky for us, Nmap is an expert cat.
And this whole process has a name, host discovery. Honestly, it's the most critical first step you can take. Think about it. Why waste hours or even days scanning a bunch of IP addresses that aren't even turned on? We want to be efficient. We find the live hosts first, and then we dig deeper. And our go-to tool for this is, of course, the powerhouse that is Nmap.
Now, you might be thinking, hey, why not just use the good old ping command? It's a fair question, but here's the problem. A standard ping uses something called an ICMP echo request, and pretty much any modern firewall is configured to just drop it. It's like sending a letter that the post office is trained to immediately throw in the shredder. The target never even sees it, and you're left thinking nobody's home.
So that brings us to the real question. If knocking on the front door doesn't work, how do we find out if anyone's inside? Well, this is where Nmap really shines. It doesn't just knock on the front door and then walk away. Oh no, it's got a whole ring of keys for the side doors, the back windows, you name it.
The solution is to think of Nmap as a specialized toolbox for host discovery. You wouldn't use a screwdriver to hammer a nail, right? It's the same idea here. We've got different kinds of pings. Some use ICMP, some use TCP or UDP, and some use ARP. Each one is a totally different tool, built for a very specific job.
Let's start with the most familiar category, the ICMP pings. Now, we already know the standard echo request is usually a no-go, but Nmap has a couple of other ICMP-based tricks up its sleeve that can often sneak past a lazy firewall.
So if your standard echo ping fails, your very next move should be to try a timestamp ping or a netmask ping. Why? Because system admins almost always remember to block the standard echo, but they often forget about these more obscure, less common request types. A response to either of these is a dead giveaway that the host is up. It's a super quick way to score a win. Okay, but what if the firewall is configured to block all ICMP traffic? They've locked that whole category of doors. This is where we get really clever. We stop sending ICMP packets completely, and instead, we start speaking the language of the internet. TCP. We're about to probe the firewall's blind spot.
The first tool we'll grab is the TCP SYN ping. This sends a packet that looks exactly like a legitimate attempt to start a new connection. You know, like your browser asking to connect to a website. If the host is alive, it'll send back a SYN/ACK packet to say, sure, let's connect. And boom, we have our answer. And we did it without ever sending a blocked ICMP packet.
And we can be really strategic about this. We don't just blast these SYN packets to random ports. We aim them at ports that are very likely to be open, like port 80 for web traffic or 443 for secure HTTPS traffic. Doing this just dramatically increases our odds of getting a response back.
But what if you're up against a savvier firewall? One that's actually stateful and on the lookout for those new unsolicited SYN packets. Well, then we pull out an even stealthier tool, the TCP ACK ping. Instead of trying to start a new conversation, this packet pretends to be part of one that's already in progress.
Let's compare these two, because it's pretty brilliant. The SYN ping is like asking, hey, can we talk? A yes reply proves the host is there. The AC ping, on the other hand, is like saying, hey, just continuing our chat to a system you've never spoken to. The system, totally confused, is going to reply with a reset packet, which basically means, what are you talking about? We're not having a conversation. And that very go away message is proof that it exists. Two totally different approaches both get us the confirmation we need.
Okay, we've covered ICMP and we've covered TCP, but we still have two very powerful, very specialized tools left in the box for those really stubborn targets. Let's talk about UDP and the king of local scans, ARP.
So, the UDP ping is a bit of a weird one. You send a UDP packet to a high-numbered port that's probably closed. And here's the trick. If the host is alive, its operating system is polite enough to send you back an error message saying ICMP port unreachable.
The error itself proves the host is online. It's kind of slow, yeah, but it's fantastic for finding hosts that other scans might just completely miss. But what if you're on a local network? Is there a method that's basically 100% reliable? You bet there is. And it works because it operates at such a fundamental level of networking that devices simply cannot ignore it if they want to communicate at all. That unbeatable method is the ARP ping scan. See, on a local network, devices use physical MAC addresses to talk to each other. An ARP request is basically the network equivalent of shouting, "Hey, who has this IP address? I need your MAC address." For any device to even function on that network, it must respond. It has no choice. And that's exactly why this scan is so blazing fast and incredibly reliable for local discovery. So we've covered a whole bunch of awesome tools: ICMP, TCP SYN and ACK, UDP, and ARP. The big question now is, how do you decide which one to use? Let's tie it all together with a simple, practical game plan. All right, here's your cheat sheet. It's a simple flowchart. First question, are you on the same local network? If yes, just use an ARP scan. It's the best tool, period. Okay, if you're scanning over the internet and the standard ping is blocked, your next move is a TCP SYN ping. If that gets blocked, you escalate to the stealthier TCP ACK ping. And finally, if it seems like all TCP traffic is getting filtered, you pull out the UDP ping. It's a simple, logical progression from fastest to most specialized. So the real takeaway here is this. Becoming great at host discovery isn't about memorizing one command. It's about thinking like a problem solver. It's about understanding the environment you're in, predicting the defenses, and then reaching into your Nmap toolbox to pull out the absolute perfect tool for that specific job. You now have the full playbook. You have the knowledge to find pretty much any active host on any network, whether it's out in the open or trying its best to hide. That critical first step of discovery is done. So the real question is, now that you can see them all, what are you going to discover next?